So, everyone, thank you for attending today's webinar. So, I will not introduce myself first. It's just a quick disclaimer to say for the audience that is not coming from Korea that the main webinar will be held in English, but the introduction will be held in Korean. And for the Q&A session, it will depend either in Korean or in English. So I will let Mr. Dio introduce the webinar in Korean, and I will begin just after this. So thank you very much.
Thank you, Thibault. 네, 안녕하세요. 저는 금일 진행 예정이었던 장석 부장이 사정이 생겨 대신 진행하게 된 로터스 정보기술의 남도 차장이라고 합니다. 우선 바쁘신 와중에 저희 웨비나에 관심을 가지고 참석해 주셔서 매우 감사합니다. 저희 로터스 정보기술은 오픈소스인 카펠라 개발사 오베오사의 파트너로서 국내 카펠라 도구를 공급하고 지원을 맡고 있는데요. 근본에는 오베오사와 함께 카펠라와 아카디아 반복론에 대하여 소개 웨비나를 진행하게 되었습니다. 금일 발표를 맡은 티보는 현재 오베오사 소속으로 일본 및 한국 시장에서의 MBSE 관련 비즈니스 디벨롭먼트를 담당하고 있으며 아울러 오픈소스 MBSE 모델링 도구인 카펠라, 아카디아의 관련 프로모션 및 MBSE 기반 시스템 개발 자문 및 컨설팅을 수행하고 있습니다. 웨비나 도중 궁금하신 사항이 있으시면 Q&A 창이나 채팅창에 남겨주시면 추후 답변 드릴 수 있도록 하겠습니다. 그럼 카펠라 및 아카디아에 대한 소개 웨비나를 시작하도록 하겠습니다. Thibault, would you start for the presentation?
Yes, thank you very much for your introduction. Okay, thank you everyone for attending today's webinar. So my name is Thibault France. I'm from France, obviously. I'm based in Japan and I'm a business developer for Obeo. So my goal is to expand the footprint of Capella in the Asia Pacific region. So I'm based in Japan, but I'm also in frequent contact with the Korean market, thanks to LOTUS Technology, who is organizing today's webinar. So this presentation, like I said in the beginning, will be held in English. In the middle of this presentation, we will have a demonstration of the Capella tool. And then after a Q&A session, so the presentation will last for something like 40 minutes or something. So first thing first, let me talk about Obeo and its involvement in Capella. Obeo, we are a French company, so our headquarters is based in France. We are specialized in modeling technology, modeling software. For Capella, it was firstly developed in partnership with Thales. So it means that the first deployments that we made were primarily in aerospace and the defense sector. But nowadays, it's pretty diverse. We have a lot of traction in railways, in the automotive industry, in space in general. And so the three main software that we have developed is first Sirius, which is a domain-specific modeling tool, Capella, which I will present today, so MBSE, and the third is Obeo Smart EA, which is an enterprise architecture tool. So like I said, I'm based in Japan, and I have colleagues all around the world, so in Canada, in Brazil, Australia, India. So before we get into Capella concretely, I will explain very briefly the Capella history, if I can say. So in 2005, inside Thales, they wanted to implement MBSE. And so in 2005, it was quite pioneering. But they faces some challenges because, well, the engineers have had difficulties to get into the process, and also SysMLv1 was complicated, if I can say. So people didn't really want to get into it. So what they did is that they sat around the table with all engineering team inside Thales, and they came up with a methodology a process to help engineers in their designing processes. So this process, this methodology, it is called Arcadia, and so it's an invention of Thales. And then in 2007, they asked us, Obeo, to help them build a software to implement this methodology. And this software is called Capella. So at the very first, it was a software that was inside Thales. And for example, in 2009, they firstly they used Capella internally for their project, and it was considered pretty much a mature product. The big change for Capella came up in 2014 when they decided to put Capella open source. And so with the open source change, there was also the first deployment of Capella outside of Thales. And nowadays it's quite diverse. We have a great dissemination of Capella. We are the most used MBSE software in Europe, and we are fastly developing in North America, South America, and in Asia. So the legitimacy of Obeo in the context of Capella can be attributed to its expertise, experience, and contribution to the development and support of the Capella modeling tool. Obeo has been actively involved in the Capella project, collaborating with the Capella ecosystem and contributing to its enhancement. Obeo in-depth knowledge of Capella architecture, coupled with its proficiency in modeling technology in general, position the company as a key player in providing valuable services, support, and innovation within the Capella environment. So let me briefly introduce MBSE, but I think you already know what it is. So we can say nowadays that the complexity of our systems never stop increasing. They are more and more interconnected. There is also new type of discipline that have emerged, such as AI, UX, etc., etc., and more interaction between our engineer and for example, stakeholders in general. And it's creating, we can say, a communication and an information management problem between our engineers and engineering disciplines in general. So at Obeo, we believe that model-based system engineering, MBSE, is a key technology for solving this challenge. System architecture models that are created by system engineers now play a key role. They act as a single source of truth and a backbone for both managing and structuring engineering data, as well as acting as a central point for cross-engineering activities, greatly enhancing communication between project stakeholders. With a model-based system engineering approach, models are structured digital assets that represent a consistent and integrated representation of the system. These models help automate many value-added activities that will be very difficult, time-consuming, and error-prone if done manually. So let me briefly introduce you about Capella. So Capella, it's an open source, like I said, modeling tool with a very specific focus. It is dedicated to helping system engineers build better system architecture. The main high-level objective when using Capella are, first, to better understand the customer need, then to define and share the solution among stakeholders. Then one very strong objective is to secure the system, subsystem, software, and hardware engineering, and to prepare subcontracting. It can also be used to early evaluate and justify architectural design against engineering specialties, and then to prepare and master validation and verification activities. One of the main differentiation about Capella is that it comes with a method, and this method is called Arcadia. And Capella, it's the modeling tool that implements the Arcadia methodology. So let me introduce you to the Arcadia methodology. So the most important point to remember about Arcadia is the following one. Arcadia, it drives you to adopt a certain perspective to ensure the consistency and completeness of your architecture design. Arcadia is based on 5 engineering perspectives, and for each of them, we have a summary of the task, concept, and objective. The two first engineering perspectives are focused on capturing the need. It's the two at the beginning, the operational analysis and the functional and non-functional need analysis. So in the first one, the operational analysis, you're going to build a model that focuses on what the stakeholders need to accomplish, what the stakeholder of the system need to accomplish. On the second one, the system need analysis, you will focus on what the system has to accomplish in order to fulfill the needs of your stakeholders. Then, the next two engineering perspectives are focused on capturing the solution this time. So in the first one, the logical architecture, what you try to do is to explain how the system will work in order to fulfill its expectation in a logical way, hence the name logical architecture. And in the final one, the physical architecture, we will build a model on how the system will be developed and built concretely by making technological choices. So I will briefly introduce you to the main concept of Arcadia. What I want to really stress here is that these concepts are used in every step of the methodology. So sometimes the name change, but the concept, the meaning remains the same. So if you understand them, you pretty much understand the whole methodology. So it's very easy to understand, in my opinion. So first, we use the concepts of capabilities, which are, you can see this as a partial goal for accomplishing the mission. Capabilities, they are described by functional chain and scenario. Functional chain and scenario involves function and functional exchanges. We also use actors, components, and component exchanges for structural modeling, and these functions are allocated to the components. And finally, we also have the concept for managing interfaces, as well as managing modes and states of function and components. And with this, like I said, you have an understanding of the main concept that I use inside Arcadia. So Arcadia, we can say that it closely aligns with the IEE 15388, if you know what it is. And yeah, it's true, especially so the 4 first processes, from the business or mission analysis processes to the architecture and definition processes, closely align with the Arcadia methodology, from operational analysis to physical architecture. So to sum this up, Arcadia, it's a field-proven approach. It was developed by Thales in 2005, and so between 2005 and 2010. It's a domain-specific language to ease appropriation by all stakeholders. It has been designed to deal with complexity and with size. It has been used on hundreds of users, by hundreds of users, and on a very large project, but also small one. And it's compatible with most processes, so top-down, bottom-up, iterative processes, everything. So now I will introduce you the Capella workbench, and I will go on with my demonstration of Capella. Okay, let me go into Capella. So when you are starting Capella, the first thing that I want you to recognize here is on the left of your screen, we have what we call the Project Explorer, which is the place where you will find all the projects. So today we are taking as an example the in-flight entertainment system. So what is an in-flight entertainment system? Is this thing that you will find in your plane for a long-haul flight, to play movies, game, listen to radio, those kind of stuff. So when I am starting a project, so it can take a bit of time, the first thing that I see is the Arcadia methodology. And it was not just a way of saying earlier, like the methodology is at the core of Capella, it's the first thing you see, and it's the main thing that you will follow during your design process. So you can find the main steps, so operational analysis, system analysis, logical architecture, physical architecture, and EPBS, but we will not really cover this today. So let me show you with a diagram the main functionality of Capella. So when I'm clicking, I did that. When I'm clicking on a step, I come to these pages with a sub-step, if I can say, so with different diagrams inside it that correspond to a specific task, a specific things that you want to do in this bigger step, so the operational analysis. And when you are clicking on a sub-step, so today's we will do this, define operational entities and capabilities. If I'm clicking on the two little yellow arrow here, it will show me all the existing, on the right, all the existing diagram that have already been built. So this in-flight entertainment system, it's the base project. When you download Capella, it's already here, so you can already have everything that I will show you today. But yeah, so we have existing diagram, and that's what we are going to explore today. So, okay. So before going inside this diagram, which is pretty simple, I will just explain you the layout of Capella. So first, in the middle of the screen, we have what we call the workbench. So really in the center. So this is where you will model pretty much everything. When you are double clicking on the center, you can have a kind of a full view of your diagram, which is very convenient when you want to really focus on that. But you just have to double click on the title. So on the left, like I said, we have the Project Explorer. On the bottom left, we have the outline. So what is the outline? It's not very useful for this diagram, but for example, if I zoom in my diagram, it will show me the entire diagram on the bottom left. For example, if you have very, very large diagram, it's an easy way to see where you are in your diagram. So it's not very useful for this because it's a small diagram, but still it can be very useful. On the right, we have the palette. So the palette is your main modeling tool available here. So it's very easy to use. For example, if I'm clicking here on operational actor, I can click and add like this a new actor, whatever. So you can make connection between them. So this is the palette where you will find all your modeling elements. But I'm not gonna create a new one here. And finally, one thing that is very important in Capella, it's what we call the semantic browser. So at the bottom of your screen. What's the semantic browser? For example, if I'm clicking on any element of the diagram, it will give me more information on these elements. So here I'm clicking on pilot. Okay, so clicking on pilot, I can resize it for you so you can better see it. It will give you more information on your actor. So pilot, it's an actor. I can see that it is a member of something that is called crew, of an operational entity. I will explain the concept just after. And this pilot is present in all related diagrams, so everything that you can see here. These elements, so you have the reference element and you also have the referencing element. So in which element are using this pilot, for example. So you can see here that in involving operational capabilities, we have perform flight onboard announcement. And yeah, that's true. When you looking at on the model, perform flight announcement is directly linked to pilot. So it's another way to explore your diagram. It can be very, very useful. Okay, so explaining a bit what you are seeing here. So first, in a gray color, you will see actors and entities. It's pretty much the same concept. The only difference is that entities, operational entity, can be subdivided in a smaller actor. For example, in the airline company, this one, which is OE, operational entity, you can have the CEO, the marketing team, etc., etc. So smaller group of people. But an actor is indivisible. So the pilot, there is only one pilot. You cannot divide it. Same thing for passenger, for example. Cabin crew, for this example, we assume that there is one cabin crew, but obviously if there is a crew, it will be an operational entity and each member of the crew will be an actor. But it's not really relevant here. On the left, we have the operational capabilities. So going back to my PowerPoint, capabilities is a goal that needs to be accomplished by my users or operational entity. So here we have three operational capability. The first is entertain during flight. So that's the main purpose of an IFE system. We have perform flight onboard announcement. So for example, the pilot saying that we will land soon, that there will be turbulence or something like this. So this capability is not directly linked to the passenger, but it's a need of the cabin crew. To say that the diner will come in 30 minutes, for example, and to the pilot because maybe the pilots want to say something to the passenger directly. And the final one here implements a commercial strategy which is not directly linked to actors, but more for the airline company. So I will explore today the entertain during flight. So clicking on this and showing on my Project Explorer, what I want to show you is that on the diagram, the entertain during flight is linked to the passenger and the cabin crew. But when I'm clicking on operational capability here, I can see that in the reference element, I have another one. So I have the passenger, yes, the cabin crew also, but I have also the aircraft, which is not here. But it's not shown, but it's present in the architecture of your model, if I can say. And if you want to add this, it's very simple. You just drag and drop it like this, and you put this in your modeling. So it's very simple. Okay. So now I have all in this diagram, all actors and entities linked to this operational capability. What I'm seeing here also, maybe I will zoom a bit. What I'm seeing here is that this operational capability has 3 little dots. And what's the meaning of that? The meaning is that this operational capability has been answered or explained in a diagram. And here we are talking about a scenario. So remember in my presentation, I said that capability can be explained by scenario and also functional chain, which I will cover a bit after. So this is, I will put it in full screen. This is the way that my in operational analysis is answered for this capability entertain, was it that? Yeah, entertain during flight. So this is a scenario and it's a way of presenting the interaction between those different actors. So we can see the cabin crew, the aircraft, and the passenger. We have this, which are phases of my scenario, and exchanges between the different actors. So for example, in the boarding phase, the cabin crew will ask the aircraft to play some ambience music, and the aircraft will play this ambience music to the passenger. Same thing for the takeoff. During the takeoff, the cabin crew will ask the aircraft, or let's say impose to the aircraft some safety instruction, and the aircraft will, for example, play an imposed movie just before takeoff. During the cruising phase, the passenger can ask for a movie, and the aircraft will play the movie. He can ask for music, same thing. And if he doesn't ask for movie or music, then the aircraft, with the else, will play the moving map, for example. That's just an example. It's very oversimplified, but that's what I wanted to show. Okay, and okay, same thing for the landing, safety instruction passed through cabin crew to the aircraft, to the passenger, etc., etc. So It's not very complicated to understand. What can I also show you in the operational analysis? Here, it's what we call an operational architecture diagram. So in the existing one, I will open this one. Okay, so what can we see here? So we kept the same color pattern as before. So in gray, we have the actors or the operational entities. And remember what I said, that an operational entity can be divided into actors. We can see it here. For example, we have crew, which is divided by pilot and cabin crew. And noticing that, for example, the exchanges are going from pilot and cabin crew and not directly from crew, but really from actors. Okay. Each entities or actors will be, which we will have what we call, operational activity will be assigned to those actors. So here we can say that the pilot will make a priority audio announcement. This priority audio announcement will be passed through this link, priority audio announcement, to the aircraft, and the aircraft will broadcast the audio. So it can be audio announcement for the pilot, ambience music, music selection, etc., etc. So that's not very complicated, and we can also see here in blue what we call a functional chain. So a functional chain, it's like I said, it's a way to explain a goal of my system. So here, for example, I have perform audio announcement. Which can be seen as a goal, and how this goal will be fulfilled. Well, it will be fulfilled by first the cabin crew will make an audio announcement, it will go to the aircraft, and finally to the passenger. So it's pretty much it's looking like this a bit. So let's say communication between actors, but it's another way of representing it into your diagram. Okay. Very briefly, I will go to system analysis, but since I've not much time left, I will go it. So going into system analysis. So same thing, I have sub-steps, and here I have what is called transition from operational activities. So everything that I've created in the previous step, I can transition it to the next step. I can select, for example, if I'm clicking here, I can select which part I want to transmit. For example, I'm not obligated to transmit everything. I can choose and manage this. Okay, so in the previous step, we were not talking about the system, but the actors and their needs. And here we are talking about the system needs in order to fulfill the actor needs. So when I'm clicking, for example, on this, I can see the disposition. So my different actors, the passenger, the aircraft, the cabin crew, and my system, which is in the middle. So that's the first thing. Here we are concentrate on the system. That's what we want to explain in this part. So for example, let me show you what we call a functional breakdown diagram. So it's this one. Okay, what's the purpose of this? So I have my IFE system, which is my main system, with different tasks different action that he need to perform. And in this diagram, I will try to subdivide this task into smaller parts and to start to refine my function. So for example, my IFE system need to provide access to digital media. Okay. So in order to do that, he will need to load this digital media and to store this digital media, etc., etc. So I will not go on everything, but that's the way of thinking. Then, finally, this function will be allocated. So which one is? I think it's this one. Sorry. Yes. Okay. So here we can see first that the IFE system is in the middle of my design work, and the actors are on the side, because the main focus is here to explain the needs that need to be answered by my system. So what we can see is that the function, the action is are allocated to different parts of my system or actors, and those functions will be linked by functional exchanges, those arrows, that will transmit an order, a data, anything. Okay, final thing that I want to show you is functional chain. So remember, I said that capabilities is either a scenario or a functional chain. So here, for example, I can add an existing functional chain like this. So I'm clicking on the functional chain, and I'm adding whatever broadcast audio announcement. So I'm clicking on the left arrow, clicking OK, and here, ta-da, I have my functional chain that is coming up, which is broadcast audio announcement, and it show me how this functional chain is, let's say, displayed in my diagram. So the aircraft will send an audio announcement via an audio stream. Then my system will manage the video and audio diffusion. So it can be an announcement from the pilot, but it can also be the radio, a movie, or whatever. But here it's more the radio because we are talking about audio. And then it will transmit the audio signal to the passenger who will listen to the audio announcement. And it's a way of answering the capabilities, like I said. So, for example, perform audio announcement. Okay, so I need to wrap this up. There is many more things that I wanted to show you, but I'm quite running out of time. So logical architecture, it was more about component, and physical architecture, more about concrete technological choices that you will make. But I'm sorry, I will need to get back to my PowerPoint. Anyway, in the Q&A session, we will have time to go deeper in that if you want. Okay, the more you will discover some new features, as it is quite a rich environment. There is many things to explore. The most important point, however, is that Capella, it comes with an embedded MBSE methodology, Arcadia. So in other words, this means that the method is already there, and that the tool has a lot of features dedicated to supporting this specific method. We name some of them modeling accelerator or engineering helpers. These features are here to ease the day-to-day work of system engineers, improving also their productivity. So using Capella means that you can really concentrate on doing system engineering work rather than struggling with modeling and processes. So to summarize what we've seen so far about Capella, we can say that Capella, it has a focus scope, which is helping system engineers to build good system architectures. It comes with a mature methodology that has been used for more than 10 years in hundreds of companies and thousands of projects in all industries where system engineering is used. This method is implemented in a pragmatic tool that was created specifically by system engineers for system engineers, and everything is available for free because it's open source again. So I will talk about some of our prestigious customers that have used Capella in their day-to-day activities and their feedback on it. So it is based on case studies that are available on our website, and I will point a link to you a bit later. So first, Rolls-Royce. What was their challenges? So they wanted to create a new engine, which is called the UltraFan. So it's the one you can see here. It's a highly complex system with many parts, many subsystems, and extreme condition, temperature, pressure variation, etc., etc. And because it's such a complex system, it has something that you might have been aware of, is what we call emergent system behavior. And so that was one of the challenges of Rolls-Royce. It was to manage this emergent system behavior as like this interaction, and this emergent system behavior can have an impact on the whole power plant. So why they implemented MBSE? Well, because the goal was to integrate requirements, define a system architecture, and ensure safety compliance. But also, MBSE was expected to solve this problem of emergent system behavior, to uncover this interaction, particularly in novel systems like in this one, the power gearbox oil system. So the result was that Rolls-Royce successfully used Arcadia and Capella to develop the whole engine federated model, improving system understanding and traceability. The subsystem transition feature in Capella, so that's something that maybe we'll have a chance to talk a bit after, but it enabled specialists to work independently on subsystem while keeping them aligned with the overall architecture of the whole project. The safety processes was also integrated into the modeling, ensuring the compliance with the standards. Then, second client, UK Atomic Energy Authority. So in the energy sector, the challenges. So they had a project that required a conceptual design for a fusion power plant by 2024. The nuclear fusion industry, it is heavily research-based, but it's quite immature in terms of engineering processes. So making system engineering a new approach for them. So why did they implement Capella? Because for them, it improved communication, facilitated onboarding and collaboration with development partner and supplier. Because of the ease of communication, it's easier for newcomers to the project to get up to speed quickly. Then it also enhances interface management, ensuring clear information exchange at all system level. So the results of the implementation. So the UK Atomic Energy Authority adopted Capella with an agile top-down approach, incrementally building the model in sprint. So the architecture definition allowed early formalization of textual requirements, driving detailed design phases, but also Capella with add-on like PVMT, which is a property value add-on, Team for Capella, which is a collaboration add-on, and M2Doc, which is an add-on that allow you to output from your model tailored Word document. It has become an authoritative source of truth, guiding the design process of all UK Atomic Energy Authority. Then, Continental in the automobile industry. So, challenges. First, it was immature and evolving requirement from end users and OEM. So remember what I said in the MBSE challenges, more and more demanding customers and end users. The complexity in defining services and product for vehicle connectivity was one of the challenges, and there was also concern around safety, security, and viability in system architecture. So to overcome this, they adopted Capella to design system from requirement to deployment, to improve collaboration between system architects and stakeholders, and to ensure consistency in system architecture and requirement management. So the result of MBSE implementation, Capella, it is now used in 6 different organizational units across 10 locations worldwide. The MBSE approach helped them to structure operational and functional analysis with a coherent system model. The models are reusable across projects, which reduce the time spent in initial project phase, so you can reuse part of your model. It's very practical. And finally, the integration with Team for Capella, the collaboration add-on, enabled better collaboration on a large multi-partner project. Finally, DB Deutsche Bahn for railways, the challenges. They had to manage the complexity of integrating new technology like AI, cloud computing, 5G. They also had to understand the interaction between railway systems, operational workflows, and automation concepts, and to ensure the consistency across multiple engineering disciplines. They implemented MBSE2. First, the adoption of Capella and Arcadia methodology was there to structure and to guide their engineering processes. Then it has been seen as a reference architecture. It was developed following the ISO 42010, ensuring precise definition of modeling artifacts, and the system architecture was aligned with safety standards. The results of MBSE implementation was the following. So early results show that it reduced model complexity and improved clarity in system function. Capella, it enables Deutsche Bahn to make engineering decisions directly within the model, integrating functional, software, and hardware engineering. The Team for Capella add-on provided a self-service, web-based environment for managing engineering data, and overall, MBSE helped streamline workflow, enhance collaboration, and increase efficiency in railway system design. Okay, so to conclude, one other nice aspect about Capella is that we have quite a nice and active community. So you will find more information on the Capella website with, for example, the same case study that I've used today in the case study part. And we also have a YouTube channel, which with more than 100 different videos, such as webinar like today, but also tutorials, demonstration, etc., etc. So we have a website on which you can download some documentation. You can have more information about the add-on that we provide. We have a LinkedIn page. So to where we display all the future events in which we are participating, and the forum. So it's, for example, if you want to begin your journey with Capella and you have one question that you don't see an answer either on YouTube or on our website, you can ask it on the forum. And because we have quite a nice active community, you will have an answer pretty quickly. Okay, so product and services. So again, Capella, it's an open source software, but we provide, for example, capability to enrich Capella, to expand the capability of Capella. So it's the add-on, for example. We have the capacity to integrate Capella with other tools, for example, to connect it with third-party tools. And we also have the capability now to train you on Arcadia and Capella if the need may arise. So briefly on what we are commercializing as Obeo products, we have Team for Capella, which is a live collaboration add-on. Publication for Capella, which allow you to connect with third-party repositories, so requirement management tools such as Polarion, Doors, etc. Cloud for Capella, which allow you to use Capella in a cloud environment. Eco-design for Capella, which is quite new, and it's a very cool way to assess the environmental impact of your design against like environmental criteria. And then system modeling workbench, which is the integration of Capella inside Siemens PLM. If you need services related to the tool itself, like connecting Capella with other tools, customizing Capella, generating output out of Capella, we can help. This list that you can just see here represents some of the typical services that we provide for our clients. So, for example, we can develop a specific Word document generator customized to your need, which is the M2Doc that I just talked about earlier. We can extend the Capella data model and representation so that you can evaluate the architecture quality against your own parameter, so viewpoints. We can extend or customize the Capella tool itself. If one feature is not present in the tool, we have the possibility to add it for you. And we can develop scripts in Python to automate some tasks in Capella. And finally, we can simply support and maintain Capella for you. And more generally, as we are contributing strongly to the Capella development, we can help you with anything related to the tool. So we also rely on a network of partners all around the globe. And again, thanks to Lotus Technology for inviting me today. It's our go-to partner in Korea. They are proficient in Capella. They can help you. They have the capacity and the knowledge to help you with Capella. So please, if you have any question, do not hesitate. Go to them. Thank you very much. And yeah, it will be my last slide. Thank you for your attention. I hope it was clear. I think I've a little bit overshoot the time, by 2 minutes. I'm sorry for that. Okay, we can go to question if you want.
Thank you, Thibault, for great presentation and demonstration in a short time.
Thank you very much.
혹시 한국 분들께서 질문 사항이 있으시면 이제 Q&A 창이나 아니면 채팅창에 이제 질문 남겨주시면 답변 드릴 수 있도록 하겠습니다. So I think there is no questions here, but as you know, previously we had some questions about how to integrate third-party tools.
Yes.
Yep. Would you tell us how to do that?
Yes. Okay.
Yep.
So if I remember well, the question was about integrating third-party tools with Capella. So I have prepared very quickly some slides to explain this. So I suppose you can see my screen. So Capella, it's an open source modeling software for MBSE. So it's the backbone of your engineering processes, but it's not the only one. And since we have a rich ecosystem of add-ons and of collaboration with third-party tools, we have this capacity to let's say to talk with third-party tools. So for example, here you can see, and I briefly talk about this, which is called publication for Capella. So with OSLC link, so I see some question with OSLC, but I cannot read the rest in the chat. So with OSLC link, you have the possibility to connect Capella with third-party repositories. So for example, requirements management tool like Polarion, Doors, etc. You can connect also Capella with Jira. We have this connection with, like I said, the PLM of Siemens, which is called SMW. We also have this connector here with ANSYS Model Center. So it will allow you to perform some simulation based on your Capella diagrams, Capella model, like you will do with a MATLAB Simulink, for example. And so I will not go on every connector because we have a lot, and everything is not commercial. We have a lot of also open source add-on that you can definitely check. For example, this one, Dark, which implement a cyber security viewpoint inside Capella. It's very interesting. But if you don't have something that is already existing, you can either do it by yourself with something that is called Python for Capella, which allow you to script with Python your Capella environment and to do pretty much whatever you want with your data. So you can do it by yourself, but you can also contact us if you want. And we can see, depending on which tool you want to connect with, what we can do. But yeah, we have this capacity at least.
Yeah, thank you for the answer.
Yep.
Yeah, as you could see in chatting, there was a question about OSLC supporting.
Yeah, what's the question? Because I can read OSLC, but not the rest.
Yeah, yep. He said, could you explain explain about supporting of OSLC?
Yes. So like I said, OSLC, so it primarily used in an add-on which is called publication for Capella. So I have here I have a more detailed, not very detailed, but more than what I was showing to you of publication for Capella. So relying on OSLC links, we are connecting Capella with third-party tools. So like I said, third-party repositories, Polarion from Siemens or Jazz, IBM. it's also useful, this add-on, if you want to publish your model on the web. For example, if you want your manager to see your model, but you don't want him to change your model, but just to see it, to browse it, but don't have the authority to change anything. So that's a thing to report, for example, your model. That can be very useful. And with OSLC links, sorry, you can directly, like I said, connect with third-party tool, requirement management tool. It's very easy because it's like a drag and drop. So we have some video on that where you can see that you're taking the requirement in Polarion, for example, and you push it on your Capella, and the link is automatic. So it's very easy for you to do this, and so to manage also the traceability links of your requirement and to which components or function this requirement is linked.
Yeah, I think there is one more question in English. Can you?
Yes.
Yep.
What is the best thing about using Arcadia compared to SysML? Okay, so as you can imagine, that's something that we hear pretty often. So first, Arcadia, it's only the methodology. The tool, it's Capella, and yes, Capella, like you can see, is not SysML. But what I can say, the main advantage you have when using Capella is that because of this methodology, the Arcadia methodology, you are not obligated to follow each step of the methodology. You can begin at the logical architecture if you want, but let's say that these processes guides you during the whole engineering process. So it's easier for engineers in general to model because they don't have to reinvent, like I said, the wheel each time they want to do something. Also, I can say that this methodology, when it was created by system engineers. So with concepts that are more common for system engineers, maybe than SysML, for example. And okay, I was sorry. So yeah, it's easier to understand. The learning curve is easier, in my opinion, and yeah, it really drives you for certain perspective, but for me it's an advantage. Of course, it's not SysML, but we can have the capability to connect with SysML tool. But yeah, I think that the main advantage of Capella is the ease of use, the thing that it was think at the very beginning for system engineering in general, and because it's open source, with the whole ecosystem, it's much easier to implement new functionality, new add-on, etc., etc. And it's free. So compared to major player in SysML, let's say the burden is less heavy, if I can say.
예, 또 다른 질문 있으실까요, 혹시? 더 이상의 질문이 없으시면 이상으로 카펠라 소개 웨비나를 마치도록 하겠습니다. 오늘 웨비나 참석해주신 분들께 다시 한번 감사 인사를 드리고요. 앞으로도 다양한 주제로 이제 웨비나를 준비하고 있으니 앞으로 많은 관심 부탁드립니다. 요청 주신 주제나 이제 세부적인 맞춤 세미나도 혹은 웨비나도 수행이 가능하니까요. 혹시라도 필요하신 사항이 있으시면 언제든지 저희 로터스 정보기술 연락 부탁드리겠습니다. So there is no more questions. So we are gonna conclude this webinar. So Thibault, do you have any comments?
I don't have any comments. No, I think that there was one more question, but I can answer it later by email. One question that was asked before the webinar, but that's not a problem. Yeah. Effectively, we have 4 minutes left, so that's
Okay.
not a lot. Okay. Yeah, just to add something, thank you again for Lotus Technology for having us today. I hope it was good enough for you. If you have questions, do not hesitate to send me an email. This slide will be available for you, so you can see here my email address. And yeah, thank you very much for your attending, and yeah, I hope to speak with you again. Thank you, Lotus Technology. Thank you, everyone.
Thank you.
Goodbye.
Goodbye.